is Jamie.
I'm Amanda. How's everybody doing?
And we're coming to you guys to do some more Kids Discover Online. So welcome. Welcome. Yes. So our topic today, Amanda.
Water science.
What?
Alright, so H2O, we're going to be talking about water science today, doing a couple experiments, really simple stuff that you have at home once again. So let's move forward here. Alright, so water, what is it? You've probably heard H2O before.
I have, yes.
And what does that mean? Do we know what those stand for?
H2O.
Right.
Well, I have a feeling it has to do with this picture here.
Yeah, that's a good guess. That's a really good guess.
Where we've got one oxygen molecule and then two hydrogen molecules.
Right.
And when they form together, we get H2O or water.
Water.
Yeah.
Exactly. So that's what we're going to be talking about. And we've got a really simple experiment to just show you how those hydrogen molecules like to bond together.
Perfect.
So we're going to look at that quick.
Awesome. Let's get started.
So we're going to need some cups. As you've seen here, we have some tape, and then we're going to need some string. So the very first thing that we want to do is actually start to get this string wet.
Okay.
So that's what this bigger cup of water is for, just to get your string in there. And then I'm just going to kind of leave that off to the side for a second. But you do want to make sure to get the whole thing. All right. There's that.
Perfect.
All right, and then we're going to take some food coloring just so we can see it in action a little bit better. I'm going to use blue. You can certainly use whatever color you have at home. If you don't have food coloring at home, that's no problem too.
Okay.
So we're going to put in just a few drops of that so we can see. Perfect. And you can stir it together. I'm just going to swish it around today until it gets mixed there. All right, so from there, the only other thing that we need to do now is we're going to tape our string into the bottom of this cup. And so that's what our Scotch tape is for. And we'll see how well my string wants to tape down there. Now that it's a little wet, I'm going to wring some of that water out of the bottom. All right, put our piece of tape in and see if I can get my hands down in the bottom of this glass.
Maybe we should have picked a bigger glass.
Could have picked a bigger glass. Could have picked a bigger glass for sure, but hindsight, you know? All right, there we go. And it doesn't have to be all the way at the bottom. It can be on the side like that. So we just really want it to kind of stay in there. Hopefully that will be the case. There we go. Okay, so from here, we are going to take this string and we are going to put it in our opposite water right here.
Nice.
All right, and so what we want to do is see if we can get this water to travel all the way down into this cup.
Like, are you going to pour it?
I'm going to pour it, but I'm going to pour it from a ways away.
I feel like you're going to spill water everywhere.
Well,
like it's just going to travel on the string?
That's the hope, if I pull this off correctly. So, all right, so what we're going to do, and I'm going to hold this just to get it tight to start off.
Okay.
And we're just going to start pouring a little bit. And if you can see, our water is traveling down our string.
And it's not spilling down here.
Wow. Nope, not spilling. Oh, our tape didn't want to hold. I was a little worried about that since I got my string so wet. You might want to tape that a little bit, but there we go. I'm going to hold it down there. But as you can see, we're doing a pretty good job of having the water travel right down the string. Now, Jamie, do you know why that's happening?
Well, it's almost like the water is grabbing onto the string.
It is grabbing onto the string.
Or each other?
So, it is grabbing onto the string.
Okay.
There's one other thing that I want to do now. We're going to use a string that we didn't put in the water, and I'm going to hold it kind of in a similar place.
Okay.
Just so we can see what happens if you don't put it in water and see how well that works. I am going to put it down here, and let's see how well it wants to travel.
I feel like it's not traveling very well.
So, no, you know what? I think as my string's getting a little wetter,
Right,
it's
it's
starting
starting
to
to travel more,
Right,
but it's still dry down here, so it's not really continuing down.
exactly. So when you first see it, you think, oh, well, obviously the science is happening there. The water is getting quickly absorbed onto the string and it's going right down.
Sure.
And that makes sense. And I think visibly that's what you're thinking, but it has to do with those hydrogen bonds, right? Because those water molecules love to go to other water molecules. They love to go right to them, and so it's called cohesion, right? When these type of molecules like to stick together, and those hydrogen bonds are super, super strong. So if you get them wet, it's actually the water liking to stick to the other water, not so much liking to stick to the string, as we saw. So give that a shot. Definitely maybe put something down on the table if you don't want to spill everywhere like I did. But we do have one more water experiment for you today, and I think Jamie's got it pretty much set up over here.
Yeah, so for our last experiment we're going to do, it's going to be like a density column. So we talked a couple experiments ago about like density and what is density. So, forgot to advance this. So density is how tightly packed your molecules are. So on this picture, you can see these molecules are really close together. That's because it's really tightly packed. And I think you said this was a sugar crystal?
It is a crystal.
Yeah.
Yep.
So you can just see, like in that, it's really tightly packed. Those molecules are really close together. And so we wanted to kind of play around with the idea again of different densities with different liquids, so we can see, we talked about if things are more dense, they sink to the bottom. And if things are less dense, they kind of float on top. Well, what if we have 1, 2, 3, 4, 5, 6 different liquids and we put them in our container? What happens?
Ooh, I can't wait to find out.
I know, and they are all different densities, believe it or not.
Okay.
So to start us off, I've got just some honey from my house. I'm gonna just take the lid off completely because I'm gonna try and put some nice thick layers in here so you can see the differences. So here we've got some honey.
And that's just going in completely
completely as it is. I did not
Okay.
put any food coloring in this or anything like that. And the trick that I'm gonna try and do with all of my different liquids is pour right in the middle of my container, so that I don't get anything caught on the edge.
You don't want anything on the side.
Right, because like honey, when I was pouring it, you probably saw it was really thick. Just like our next liquid is going to be corn syrup. So I don't want to get a lot of stuff stuck on the sides of the density column. I just want us to get some really good layers. Amanda, how does that look?
That looks really good.
Okay, perfect. So I think
And
it's
for
enough honey.
honey lovers out there, probably looks really great.
I love honey. So our next one we've got here is some corn syrup. And I thought the corn syrup and the honey are pretty similar in color. So instead I would add a little bit of green because it's like my favorite color. So why not?
Indeed.
And this is, again, pretty thick. So I'm trying to put it in the middle rather than on the side. So I don't have any green liquid catching up on the side. I'm just gonna try and pour it in. And another trick is to kind of go slow. If you start to do too much too quickly, then you might get some heavy mixing happening.
That looks really cool. So what are we seeing already? It kind of looks like, is that staying on top or is it going in mixing?
I don't know. I got a good warp here from the vase. So let's see. It looks like it's staying on top, but it almost created a crater. I think because I put too much in at once, so it kind of pushed down and made a little bit of a crater, which
Interesting.
is actually kind of neat.
Yeah, that's really cool.
So, I mean, now
What's
I
next?
learned I did too much to begin with. So next I have some dish soap, and dish soap, this one's just blue, so I thought I don't need to add any colors again. So I'm gonna go a little bit slower this time than I did with our corn syrup. So I'm just gonna add some dish soap here.
Oh, wow. You can see it's like staying right on top there.
Yeah, it's kind of neat how it's there's almost like a little barrier, almost, between the two liquids.
Oh gosh, that looks really cool with the different colors.
Can you see it pretty good?
Yeah.
Nice. So So I think it's good that I've got my blanket layer across, so I can maybe increase how much I'm pouring. Is that good?
Looks really
Ooh,
awesome.
I love that blue next to that green. That really pops. So then our next liquid is water, but water and soap will mix together. Looks like Stephanie kind of zoned out for a second. Water and soap do mix together, so I have to be really careful with this step because if I pour too quickly, then it's gonna start to bubble up and mix up. So I have to be a little careful. I just have these little tiny pipettes. I don't have any big turkey basters, so if you've got a turkey baster at home, that's something that you could use. And I'm just gonna be real careful again to add it on top. Looks like Amanda is helping me out. Good assister here, thank you.
What is an assister?
An assister is a made-up word we came up with a couple online Kids Discovers ago, where we essentially just said, you are a helper. You are assisting me with a task. You are an assister. So again, I'm trying to go slow because if I go too quickly, then you start to get the mixing of the soap and the water. How's it looking, Amanda? Can you start to see a little bit of definition happening here? It's probably hard because there's not much water.
There's not too much water yet, but you can certainly tell that there is some water on top.
Perfect. So
And it's kind of looking, I think because of the refraction of the glass, it's looking a little blue.
Oh, sure.
But it's definitely lighter blue.
Good. And the water, I'm not too concerned about getting on the side of the glass because that is not going to leave streaks.
Yeah, that's starting to look really good.
Is that looking better?
Yeah.
Just keep doing this magical movement here of sweeping along the side. Thank you for bringing me this larger kind of dropette. Again, you could use a turkey baster at home and then it's even bigger.
Yeah, go a lot faster.
And it would go a lot quicker. But again, remember, patience is the name of the game here. You don't want to go too quickly because then you'll mix it up. Think that looks pretty good?
Oh yeah, that looks really good.
All right, so now I'm going to put my water to the side. And our next liquid for our column is going to be vegetable oil. So I'm going to put a little bit of vegetable oil in there. And
can you use pipette for that?
we probably could.
Yeah, that might be easier than, that's a really full bottle.
I apparently grabbed a brand new bottle. I might quickly dump some of this water out.
Yeah, let's put some oil
And then put some oil in here so that I can continue
Good call.
going slowly.
This would be interesting.
Nice. Okay, so if you can't see at home, you almost see like this little film starting to hang out on top of your water.
Yeah.
Which is kind of neat to see those little
Like oil and water,
Yeah.
definitely don't like to mix at all.
Right, like we talked about when we did our homemade lava lamps, they are immiscible. They do not want to mix. No matter how much you try, their molecules do not want to hang out together. Ooh, you can see a really good layer there of our oil.
That's super cool.
Yes. All right, so now...
the oil?
Yep, now we've got our last little bit of oil there, and we've got a really good layer. You can see our different layers. We've got our honey, and now it's kind of our corn syrup, which is colored green, has kind of risen back up above the honey. And then after that, we've got our dish soap, and then we've got water, oil, or vegetable oil, and then last we're gonna have rubbing alcohol, which is it's clear normally, so it's hard to see, so I colored it red to help out.
Gonna use your dropper again?
I'm gonna use this dropper again just so we can be nice and slow with our addition so that it doesn't...
Whoa.
Yes, isn't that red awesome?
Wow, it's like dropping down in the other layers. Like just from the impact, like you can kind of see it.
Kind of drip down
Drip
and then
down and then come back
up. Yeah.
That's so cool.
And remember, the reason these liquids are not mixing is because they are all different densities. And so on top of being different densities, they're also different polarities. So they're not going to want to mix together on a molecular level. But then because you have those different densities, you get those really cool layers and all that definition, which is really neat.
Take a look from the side now.
Yes, isn't that cool?
It's super cool.
And this is something that you guys can do at home, you know, just grabbing some things in your kitchen. Remember, we started with our honey, we added corn syrup, and then we did, I think it was dish soap, vegetable oil. I don't want to cover our cool layers.
And don't forget just the water.
Water, yes, that was actually after the dish soap, wasn't it?
Right.
And then our rubbing alcohol with our food coloring. So really fun density activity.
Yeah. And it was so simple, but it was
Yeah.
really interesting to watch everything kind of fall in there.
It's beautiful looking
It is
too.
beautiful. So that's it for Kids Discover Online today. We will be coming at you again, and like I said, if you have topics or things that you want to hear about, let us know. Certainly mention us in the comments. Send us your pictures. I would love to see what colors and designs you guys come up with your density layers. So, Kids Discover Online. We'll see you soon. Definitely try this stuff at home. All right, bye.
Bye guys, bye.